So today we're moving on to Newton's second law of motion. And so to describe second law of motion, it is a body of mass subject to a force that undergoes an acceleration that has the same direction as the force and a magnitude that is directly proportional to the force and inversely proportional to. So what the heck does that all mean? So let's break it down. So a body of mass subject to a force. So something that is being pushed undergoes an acceleration, meaning it's moving forward. It has the same direction as the force. That means it's following the same path. It has a magnitude that is directly proportional to the force. That means the greater the force, the greater the acceleration. And it is inversely proportional to the mass. So the greater the mass, the less acceleration. So to rewrite this, it is something that is being pushed and then it's moving forward and it's following the same path of what is pushing it. So the faster it is pushed, the faster it'll move. If that makes sense. The greater the mass of something being pushed, the slower it will go. It takes more force to push something bigger. And the bigger the push you make in order to make it move. So F stands for force, M for mass, and A for acceleration. So the equation for the second law of motion is F equals ma. Force equals mass times acceleration. So force is measured in newtons, mass is measured in kilograms, and acceleration, if you remember, it is measured in meters per second squared. So to find the unit for force, okay, this makes sense. 1 Newton F is equal to m, and we measure m in kilograms, times a, which a is meters per second squared. So 1 Newton, they could say 1 Newton, or they could also say kilograms times meters per second squared. Okay, so let's find the missing variable here. So we have force, we have mass, and we have acceleration. Okay, so number 1, if force is 10, so I'm going to write this over here, I don't have space. If force is 10 and my mass is 2, what is acceleration? Well, if I want acceleration by itself, I have to divide both sides by 2, so acceleration is 5. So with the same process on number 2, so 20 divided by 2 is 10, and again 20 divided by 4 is 5. To get force equals ma, so I just multiply these two, so 2 times 5 is 10. Okay, to get mass here, force is equal to 10, and acceleration is equal to 10. So I divide both sides by 10, my mass is 10 over 10, which is also equal to 1. So you want to check your answers. The way you check it is multiply these two, multiply ma. So 2 times 5, it is 10. 2 times 20, 2 times 10 is 20. 5 times 4 is 20. 2 times 5 is 10. 10 times 1 is 10. So force is equal to mass times acceleration. And force is directly proportional to acceleration. The more force you apply on something, the faster it'll go. But force is inversely proportional to mass. So how much force is needed to cause a 60 kilogram object to accelerate at 3 meters per second squared? So let me break it down a little better than I did in that chart. So m is 6 kilograms, and my acceleration is 3 meters per second squared. What is my force? Well, force is just ma. You just multiply both of these numbers, so 6 times 6 times 3, which will give me 18. So you can write it as kilograms per meters per second squared, or 18 newtons. Same thing.